right, we're back and we're going to take a look at second day here, talking about the quadratic formula and the discriminant. That's section 6.5. We're going to do part 2. And today I just want to focus on the story problems and take you through how to use the calculator to do that a little bit. Since we're using the quadratic formula, things can be a little bit messy in terms of the numbers. They could be a lot of decimals involved. So let's take a look at how we do this. Let's start with one of the word problems right out of the book. All right, we're on page 318, and this is problem number 12 and 13. The physics problem. The height h of t in feet of an object t seconds after it's propelled straight up from the ground with an initial velocity of 85 feet per second is modeled by this equation here. Now we're gonna walk through again on what the basic raw formula is for this, and then we'll show you that they plugged in the numbers, but you can see that 85 feet is the initial velocity when the thing was shot straight up, and it says that it was shot from the ground, so we're going to talk about that too. And then it asks the question, when will the object be a height of 50 feet? Well, let's take a look at what that looks like. Okay. Alright, so here's the basic formula for gravity, and you notice that we've got lots of things here. Let's go over them again. Negative 16 is the speed at which an object will fall. Negative means it's going down when it falls. T is the time that's elapsed. V sub 0 here means the velocity when the time is 0. In other words, when you shoot the thing off. If this is a positive number, that means you shot it up. If this was a negative number, it means you threw the thing down. H sub 0 is the height when you shot the thing off. So if you're standing and a certain distance off the ground, you'd put a number in here. If you shot it off from the ground, you'd put 0 in here. And that's what we did in our situation. We shot it off from the ground. So that's 0. And then h of t is the height at any moment in time that you can calculate. You can find the height at any particular point in time. Well, they're asking us in this problem to find the height, to find the time when the height is 50. So let's put the numbers in here. And you notice that the initial velocity was they shot it upward, positive, 85 feet per second. So there's the formula. And this is the formula they gave you in the book without the 0 here. I just put that in there for emphasis. But, and the 50 feet is the height we want to find the time of. Okay? So we're going to be able to solve this if we use the quadratic formulas, but we got to first set it equal to 0. So let's move this over to the left. Excuse me. Move it over to the right. And now it becomes negative 50 over here. Alright, we're going to use the quadratic formula here. And we're going to go to our main work screen and plug this in and see if we can calculate the value of t when the object is at 50 feet. Now remember, we're shooting this thing off from the ground, and it goes up in the air and it comes back down to the ground. But we want to find the time at two places. It's going to cross 50 feet there, and it's going to cross it here. There are two places at which this object is 50 feet. And that makes sense because squared, t squared or x squared, equations, quadratics, always have two answers. So we're going to come up with two answers here, and we're going to use the calculator to do that. By the way, remember the formula is negative b plus or minus, we'll get two answers there, square root of b squared minus 4 times a times c all over 2a. Now notice a couple things here. This long line means that the top has to be in a parentheses and the bottom has to be in a parentheses. This line, this division line, acts like a parentheses. So we're going to put these in here just so you can see them, and here too. So we're going to plug these numbers in, okay, and I'll walk you through each of those numbers. Remember, this is A, this is B, and this is C, and we're going to plug those numbers in to our calculator. Alright, let's go ahead and plug these numbers in. Negative b, now I'm going to start with a parentheses here. Negative, notice I'm using the negative sign here and not the subtraction sign. Negative b Plus or minus, well, we're going to do one at a time. So here's the plus sign. The square root of b squared. Well, b is 85, so 85 squared minus, subtraction sign here, not negative sign, minus 4 times a, which is a negative 16, times c, which is a negative 50. Now I need to get out from underneath the square root, so I'm going to hit the arrow here, move over, and close that numerator. The numerator of the fraction is now closed. By the way, if you don't get out from underneath that radical, you'll have the parentheses in the wrong place and it won't work. So very important we get those parentheses in the right places. All right. And then divide by parentheses 2 times a, negative 16. Okay. And let's see what happens if we hit enter here. All right, we get a big long decimal there. Let's jot that number down. It's about what? Point, put it right here, 0.67. We'll just round it off, 0.67. One of our answers is 0.67. Okay, that's about 2/3. Now that's just one answer. We have a second answer, and rather than having to type this whole thing in again, we're going to use the entry feature. It's on the equal sign, or excuse me, on the enter button down below, and I'm going to hit second entry, and you'll notice it pulled the same equation that I just entered up here into the calculator. Same equation, okay? But what I want to do is change this plus sign over here. So I'm taking my cursor over and change the plus sign right here to a subtraction sign. Not a negative sign, but a subtraction sign. So that will find our second answer, and it's a way to avoid having to plug in all those numbers again. Let's see what happens now. I'm hitting enter, and I get a second answer, 4.64. 4.64. So the other number is 4.64. There's your second answer. Okay, now let's see what that means. Let's go interpret the graph. Let's back up a little bit here and take a look at it. And there's your graph here. Okay, it crosses at 50 feet at two places. This one's got to be over here because it's smaller number. And this is about right here. This is about 0.67 seconds, about 2/3 of a second. And then this one here has to be about 4.64 seconds. This is time. This is in seconds. So you'll see that we did get two answers. The one positive one ended up over here and the negative one ended up over here. It does not necessarily mean that that the positive one's going to be to the right more. In this case it wasn't. So there are your two answers. So when it asks the question, at what time, when will the object be at a height of 50 feet, there's our two answers. At about 0.7 seconds, I'm rounding here, and about 4.6 seconds. So those are the times at which that object will be at 50 feet. Let's take a look at question number 13. All right, here we are back on page 318. 13 says, will the object ever reach a height of 120 feet? Will it ever reach a height of 120 feet? Well, that would be at the top of its curve. Well, where is that? Well, that happens to be at the vertex, at the top of the curve. Let's go take a look at what would happen here. Okay, so here's our picture, and here's the equation again. We want to know, will it ever reach 120 feet? Now, my graph here may not be very accurate. Maybe it gets up that high. It doesn't look like it here, but let's find out. That vertex right at the top of this parabola, the parabola is not very symmetrical, is it? There it is. The vertex at the top of this parabola is going to be the maximum height. It's the maximum. Well, how do you find the vertex? Well, we're going to go back to the first section in this chapter, which says that the vertex is found by going x equals negative b over 2a. That will give me the x coordinate. So I'm looking for that x coordinate, and then I'm also going to need to find the y coordinate. Okay, so let's plug this in. Negative b is negative 85 over 2 times a, which is negative 16. And let's do the math here. I'm going to use my calculator over to the side here just to do the arithmetic here. So we end up with, let's see, negative 85 divided by, I'm just going to do that math in my head at the bottom, divided by a negative 32. And I end up with an x value of 2.65625. Now it looks like it terminates there, and I wrote the whole thing so I have a little bit of accuracy here. Now that is not the height. That is simply the x value right here. That x value. Where does it reach? Right down here. And you know what? We probably could have found that by taking the average of these two. You know, it's right down the middle here. It should be symmetrical. I could have averaged these two and found that number. Well, to average them, I would just add the two of them together. So that'd be 4.64 plus the 0.67 and then divided by 2. And if I did that, I'd get about 2.655. So I could have found that x value a different way. I could have just found their average. I did it this way because I knew these 2 points already. But now my answer is a little bit more accurate here. So we're going to use the answer I got the other method, okay? Now I still need to find the y value because the question is asking for what's the height. What's the height? So let's take this and stick it back in our equation here and here. We know the time, so we're going to stick it back in there. Let's put that into the calculator, okay? Okay, let's stick this in the calculator. So I'm going to go negative 16 times x, or in this case t, x squared, which is 2.65625, and I'm going to square that, plus 85 times same number, 2.65625 minus 50. Okay, notice I used a negative sign here, a subtraction sign here because I'm subtracting. Now, turns out it didn't need any parentheses here because the order of operations is doing all the work for me. Also, I want you to notice that the 50 has a subtraction sign in front of it, but back here at negative 16, that's a negative sign. Remember, these negative signs are a little shorter. They don't have as many pixels there. So that's a negative sign. The 50's got a subtraction sign. All right, let's see what we find. It's telling us that the y value here has to be, 62.9 feet. 62.9 feet. Well, that means that it won't reach 120 feet. 62.9 feet. So as we look at our picture here, we can see that at 2.7 seconds right here, it's going to reach a height of 62.9 feet. So the answer to question 13 is no, it doesn't reach 120 feet. It only reaches about 63 feet. Okay? So this was a long problem. There was a lot to do, but you can try to see that if we find the x value, then we can find the height. You'll need to know what that vertex is in order to find the height. Okay? All right. Go look at this again if you need to. I'm going to go ahead and move to the next problem. All right, let's take a look at problem 40 and 41 on page 318 down here at the bottom. talking about bridges. The supporting cables of the Golden Gate Bridge approximate the shape of a parabola. The parabola can be modeled by the quadratic function shown there, y equals 0.00012 x squared plus 6, where x represents the distance from the axis of symmetry and y represents the height of the cables. The related quadratic equation is shown here. Okay? Calculate the value of the discriminant. Well, before we do that, let's see if we can draw a picture of what's going on here. You'll have to look at your book over to the side. I'm going to go ahead and sketch it here. All right, you can see in your book there's also a picture of the Golden Gate Bridge, but suspension bridges have towers that come down into the water. They're down in the foundation, footings are under the water there. And they have cables that are suspended like so. And then hanging from these cables are a series of other cables that support the deck. They support the deck, and they go all the way across here. They'll support the deck. Now, what it's talking about, let's back up here. I guess you can't see my picture there. There we go. Sorry about that. Let's go ahead and take a look at the picture here. Okay. Once again, there's the suspension bridge. The towers go clear down into the water, and there's a big long cable that drapes over the top of these towers, and from that is suspended these other cables which hold up the deck. They hold the deck the people drive on and walk on. Okay. Now it says in the problem that the supporting cables form the shape of, the shape of a parabola. There's your parabola, okay? And that parabola, it says, can be modeled by this equation where x represents the distance from the axis of symmetry. Here's the axis of symmetry. So x represents the distance from that axis. Let's call this 0 here. This is like the y-axis on your graph, okay? And x represents the distance from the axis of symmetry. Now we're going to go to the right here, but you could also say it's true about going back to the left here. And y represents the height of the cables. In other words, the height above the deck here. Okay. Well, the formula that they give us is y equals 0.00012 x squared plus 6. Now you'll notice that a parabola has a general form where this number, this constant at the end, is the initial height, and that's the height right here. This 6 represents the height in the center. So what it's saying is that at the center of this bridge, that supporting cable, one of these, is exactly 6 feet off of the deck. So this is 6 feet right here, okay? So now it's asking us the question, calculate the value of the discriminant. What we're not seeing here is the B value, okay? And we see A here, and we see C, but what we don't see is B. So in this case, B is 0. Oops. B happens to be 0, and C is 6. So A, B, and C. So here we go. Let's calculate the discriminant, and the discriminant is B squared minus 4 times A times C. Well, what do we get? Well, B squared would be 0 squared minus 4 times A, which is 0.00012, times C, which is 6. And we end up with 0 minus something. This is some negative number, and I could calculate it here. Not that it's necessary that we calculate it here, because we're concerned about the sign of the discriminant here. But negative 4 times 0.00012 times 6 gives me negative 0.00288. Well, what that means is that this discriminant tells us that this has no real roots. No real roots. Now, why is that important? Well, question 41 asks us, what does the discriminant tell you about the supporting cables of this bridge? What does it tell you? Well, it tells us that if there is a discriminant is negative, that's telling us that there's no real roots, that this parabola never touches the roadway here, okay? So it tells us that the parabola never touches the roadway. If the discriminant is negative, the parabola will never touch the roadway. It's actually suspended above the roadway there. That's all there was to this problem. Basically, our discriminant is negative, tells us there's no real roots. Consequently, the parabola never touches the roadway. Okay? All right, let's take a look at problems 42 and 43. The average NFL salary, A of T, in thousands of dollars from 1975 to 2000 can be estimated using this function. And you'll notice that that function is a quadratic because it's got t squared in it, okay? Where t is the number of years since 1975. Determine a domain and a range for which the function makes sense. Well, remember that the domain is x values. What are the acceptable x values? And what this is telling us is that the domain, according to the problem, has to be between 0, year 1975, again 1975 is 0, and 2000 would be 25 years later. So our domain has to be between the years 0 and 25. We'll write that here in a second. And the range is, well, we know that he's not going to get a salary less than 0, but we're going to have to figure out what that salary would be by putting that domain in here. So let's go do the problem where we're going to put that domain in from 0 to 25. All right, this time I put this equation into the y equals screen. All right, so with this calculator, oops, I had to turn my calculator, went off on you there. With the calculator plugged into the y equals screen, we're going to be able to graph a parabola. And you'll notice that the parabola, the a value here is positive. So this parabola ought to open up. And I want to take a look at this parabola, but really we're just interested in what's going on the table. Let's graph it and see what happens here. I got nothing. I got nothing on here. Well, sometimes the best thing to do when you get nothing is to hit zoom fit. And let's go down and see what fit says. Sometimes it'll look for the data and it'll plot it. There's zoom fit. There we go. Now we got a parabola. But the parabola is not really what we want. But I do know that looking at this parabola, that I got all this negative area over here that's unnecessary. I can't see all the way down to the x-axis. And I want to make sure that my parabola goes all the way to the right here. So let's go ahead and change the window. And I'm going to change my x minimum to something close to the y-axis, like -2 or something like that. And I need to have an x max. Remember that this is going to go up to the year 2000, which is about 25 years. So let's go a little farther than that. Let's say 27 years. And my x scale, well, if I go by ones, that's too many tick marks. Let's go by 3s. Okay? And then my y minimum, I want to go all the way down and see the x-axis. So let's put a little negative number in there. And we can see that our y max goes up to about 427. Let's see what this looks like now. Oh, I'm going to have to go higher here if I'm going to see the top of that. So let's go back to window and let's make this closer to, I don't know, 1,000. Let's make it 1,000 and see if we can see the end of the line out here. Not quite. Let's go up to maybe 1,500 or something. Okay. I want to be able to see the top of it. All right, I can see all the way to 25 years. Now, if you look at your graph there, each of these marks means 3. So 3, 6, 9, 12, 15, 18, 21, 24. 25's got to be right about here. If I wanted to make that easier to count, I could just change my X scale to 5, and I think I'll do that. Let's just change the X scale to 5. Okay, and that way it'll go by 5s. So now you can see 5, 10, 15, 20, 25 is going to be right here. All right, so that's what the parabola is going to look like. It goes up, and this is, remember, this is about somebody's salary. These are salaries in the NFL. And you can see what's happening is that over the 25 years, the salaries have increased dramatically. Here at the beginning, they went down a little bit, but the salaries out here have keep getting steeper and steeper graphs. So determine the domain and the range. Well, we said again that the domain X is going from 0, and I guess I can write this as a sandwich here. X is going from 0 to 25. And what we need to find out is what is the Y, the range. Well, I want to find out what the value of, this is going up, I want to find out what the Y value is at the end and also down here at the bottom. So at the bottom, that is the vertex of this parabola. So I can find that vertex using negative b over 2a, but I also want to find the top of this. So what I would do is I'd stick 25 in here for x and stick and use the negative b over 2a to find the vertex down here. So we're going to do that. Okay. All right. I went ahead and looked at tables. So I hit second table here, second table, and at 25 years, it looks like it goes all the way up to 1,201.2. 1,000. I'll jot that number down and put it over here to the side. 1,201.2. And if we arrow back and go all the way back to the year 0, let's do that. We're going to go back to the year 0 right here. Year 0 says it's at 73.7. Well, your book says that that is the low number, but in reality it's not. Look at these other numbers that are in here. Notice, according to this this equation, it went down through years, and the lowest number we have here is in year 3. It's 57.2. So the 0 is not the smallest number. Remember, a range is from the lowest, smallest number to the highest number, and it isn't at 73.7 like your book says it is. To find that spot, we're going to have to go find the vertex. We do have the high, but we don't have the low. Let's go find it. All right, I jotted those numbers down here. This was the high, and this was the value when t equals 0, but the low is somewhere near this number. And so I want to find the vertex. Remember that our parabola, the vertex is the lowest spot on that parabola. So we're going to find that by using that formula, x equals negative b over 2a. So here we go, negative b, a negative 12.4 over 2 times a, negative b over 2 times a. And if I plug that into the calculator, 12.4 divided by 4.6, I did that in my head there, I end up with this being in year 2.6, actually it's about 2.70, let's call it. We could just call it 2.7. So in year 2.7, the low would have been found. Okay, so it wasn't at 0. The low point, as we saw from our table, was actually a couple years after that, close to year 3. So we're going to take this and stick it into our equation. Actually, let's go back to the calculator. It's easier to do it back there. All right, here's our table again. And as you can see from the table, the low spot's somewhere here around 3. Okay, well, if I know it's somewhere near 3, I'm going to change my table set. Table set is found right here. I'm going to change the table set so that my table starts at, let's say, starts at 2 and then goes on from there, not by ones, but by point ones. Let's see what happens here. So I'm going to go table set. Let's start at 2 and go by, that little triangle means change in. Let's go by point ones and see what the table looks like, okay? Now, according to this, we can see where it's getting smaller. The smallest spot is about 2.7, which is what we said right here, 56.987. Higher there and higher there. So that tells us that the minimum is at actually about 56.0. 56 point, oh, it's actually 57.0. 57.0. I just rounded that off. Now, what we find is that the answer in the book is a little bit off. It's not quite right. So what do we got here? Well, the book says that the answer is when x is equal to 0, but it's not. It's actually closer to when x is equal to 2.7 or so is the low spot. So this is our low, really. Okay, so it's asking for the range. So the range, the y values, are sandwiched between 57.0 and our high, which is 1201.2. There is your answer to that problem. Okay, number 42. This is problem 42. So we have a domain. The domain, again, I'll write that up here again. The domain went from year 0 to year 25. Here's your domain. And your range is between about 57 and 1201, somewhere in there. Okay? So that's the answer to number 42. Let's take a look at number 43. All right, problem 43 says, according to this model, in what year did the average salary first exceed $1 million? Well, we're going to go back, and we can just use the calculator for that again. I want to look at the graph, and then also we'll just take a look at the calculator and see where $1 million is. Okay. All right. Let's remind ourselves that the problem said that that our graph is actually in thousands of dollars. Okay, in thousands of dollars. So 1 million would be 1,000,000. Well, we know that our graph here at 25 years goes up to about 1,200. So 1,000,000 has got to be right about here. 1 million's got to be here. And I'm going to show you two ways to do that. One is with the table. So we're going to go back over to the table, and I'm going to, let's take a look at the table again. When is this y value going to exceed 1,000? Okay. Well, this is a long way to go. Let's go back and reset our table. I'm going to do table set, and let's start at 1 and go by ones. Okay. Okay. So if we arrow down here, look for where this number on the y column is going to exceed 1,000. Looks to be right there in the year between 22 and 23. So it's exceeding 1,000,000. That's a million, right? So let's reset our table to start at 22. Okay, so I'm going to reset the table and start at 22. And instead, we're going to go by 0.1s. Okay, we're just changing the amount that it increments, that it moves up. Let's see what the table says. So if we start at 22, it looks like it's exceeding 1,000 just before 23. Well, let's reset the table to 22.9 and go by thousandths. So it's table set. Let's start at 22.9 and go by 0.01 and see if we can tell where that's going to be. So table. Yeah, there it is. I'm going by 22 point. Started at 22.9. We're going by thousandths. It looks like it's between 22.94 and 22.95. Now we can continue to do this till we get a number that's pretty close, but this is close enough. 22.95, right there, it exceeded a million. 1,000,000 is a million. So that's one way to do it, is using a table. Well, there's a lot easier way to do this. Let's take a look at that method. Okay, I'm going to go over to the y equals screen, and right here on the second y value, I'm going to make a horizontal line. And a horizontal line is just a constant number. Well, we know that we want a million here, so that'd be 1,000,000. All right, and let's draw that horizontal line. There it is. So what it's saying is that right where these two intersect is the spot at which the graph exceeded a million. Well, if you recall, we can actually find that point of intersection. And I'm going to use the intersect feature, and you've used it before, by going second, let's look here, I'm going to go second calc. Second calc, and we're going to use the intersect feature here. Okay, second calc, and we're going to go down and use number 5, the intersect feature, and we want to find where these two intersect. So I'm just going to take it with my arrow and move the cursor over in the neighborhood here, so it doesn't have to be too close. And then it's saying, is this the first curve, the one that's blinking on? Yes. So I'm going to hit enter. Is this the second curve? Now it's blinking on the red line, the horizontal line. Is that the second curve? Yes. And I'm going to hit enter. And then it's got this thing called guess. I don't worry about that. Just hit enter one more time. And you'll notice that now the cursor is blinking right at the point of intersection. And you'll notice down below here that y is equal to 1,000. It's exactly 1,000 right there. So the point of intersection is at 22.94 years. 22.94 years. I'll write that down over here, 22.94 years. And let's take a look at how that compares to the one we had before. Well, when we did it with the table, we kind of got it close to 22.95, and with the intersect feature, it's close to 22.94, very close. This one's probably going to be easier to do, and it's more accurate. So the question is asking us, at what year did it exceed a million? Well, if you recall from the problem that year 1975 was year 0, and year 2000 was year 25. So we want to go 22.94 years after that. So adding that in, that gives, so we go plus 22.94, that gives us what? 1970, oops, excuse me, 1997.94. So the year's about 1997. I just added that to this, okay? This is about 23. So that's closer actually to the year 1998. So in 1998, salaries typically increased to $1 million. Remember, that's 1,000,000. Now this was a long problem, but the calculator sure made it a lot easier to do that. All right, well that's going to be the end of this video. Now I didn't do problem 44 for you. You can do that on your own. I didn't want to spoil all the fun for you. You can go ahead and do that problem. I think you can handle it. But you kind of see how the calculator can be a big help in solving some of these problems. We've already done 12 and 13, and then 40 through 43. Make sure you go back and do all of these practice problems again where you're finding the roots and the discriminant. Okay, you may use your calculator as you think it helps you. Okay, lots of practice on this is important. This is a big deal because you're finding the roots, but you had some problems here where you also had to find the vertex. So enjoy that, and we'll see you next time.